Okay, student. So we're going to continue with the chemical energetics. The next topic we're going to discuss is about the reaction pathway diagram. What is it? It is a diagram that tells us what happened to the enthalpy of a reaction over time. Okay. The x-axis will be the extent of reaction, or we can think of them like time. Okay. Now, in the simplest reaction pathway diagram, we are going to start with a line that is depicting the reactant. Okay. For example, we can name them like hydrogen plus oxygen, and we're going to make them into water. Okay. Now, this is initially horizontal, and after the second line we're going to have is position of enthalpy for the product. Okay. Now, the product is going to be another horizontal level. It's going to be the product. Okay. And in this case, there's going to be 2H2O. Okay. We are going to connect them. The connection is often a vertical, or if not vertical, something that is a little bit slanted arrow. This arrow represents the change of enthalpy. So this is the enthalpy change. In this case, this is something that is negative because they are going down, hence it is exothermic. An exothermic reaction, the product level is lower than the reactant level. The enthalpy change represents the reaction. While if you're having an endothermic reaction, we're going to have a similar condition here, what's a reactant here. But the product is going to be higher level. Then we have the enthalpy change to be going up or positive. Okay. Enthalpy change is less than 0 in this case. Enthalpy change is more than 0 going up. We have an endothermic reaction. Okay, the features of the one here, we call them reaction pathway diagram, are the axis. It must be the extent of reaction or time, and the vertical, the y-axis will be the enthalpy. Okay. We're going to have reactant on the left side and product on the right side, okay, denoted with a horizontal line to depict their enthalpy level. Then the third one, we have the enthalpy change, which is reaction, either going up or going down. This is what we call simple reaction pathway diagram. Now, another type of reaction pathway diagram are a little bit more complicated. In this case, we're going to have 3 levels. First, we're going to have the reactant, yes. But then we're going to have the transition condition. Okay. The transition is always going up. Okay, it's going up there. Okay. And after that, we can be either going down, lower than the reactant, or going higher than the reactant. So we're going to have two going up, 2 parts, up and down. This is the intermediate or transition. And this is the product. Now in this case, we're going to have 2 directions from the reactant. Okay. From the reactant going up into the reactions, we don't call them enthalpy change, but we call them the activation energy. Activation energy is always going up. It starts from the reactant to the intermediate. The second one here is the enthalpy change itself, which is from reactant to product. In this case, enthalpy change is going down. Because in this case, enthalpy change is less than 0 going down, this is an exothermic reaction. Okay, this is the detailed enthalpy, detailed reaction pathway diagram. For exothermic. For endothermic reactions, it will be similar in that after the reactant, we're going to have the transition or intermediate. And this is the, don't forget to name the axes. Okay. The axes are what we call the extent of reaction. Okay. Now, what is difference in this is that the product level is higher than the reactant level. So in this case, we are going to have two positive value. The activation energy is always positive, and the second one, enthalpy change of reaction, is also positive. While here, activation energy is always going up. This enthalpy. Okay, so this is the reaction pathway diagram. Okay, we need to have 4 items in the more detailed one. First, the reactant, second, the product, the third, the enthalpy change, and the fourth, the activation energy. The transition itself, it is okay if we do not label them. Okay, what is more important is the label for the reactant and the product. In some other variations, it will be written as graph instead of lines. So you may have something like this. If this is the case that we have them here, then the maximum one is the transition. So the transition, instead of a line, is just the maximum point. Active energy, hence, is going to be written from the level that is the reactant up until the maximum. There, this is the active energy. And the enthalpy change from the level of the reactant, in this case, going up into the product. Don't forget to name the reactant line and the product line. Of course, because this one is endothermic, we can make a similar one for an exothermic reactions with the product lower than the reactant. It's going to look something like this. Yes. This is the reactant. This is the product. The enthalpy change in this case still going up. The active energy going up, but the enthalpy change is going to be lower. That will be it for today, and we're going to recap. Today, we discussed about the reaction pathway diagram. It is a diagram that tells us how the enthalpy change over time or as the reaction progresses. Okay. The y-axis is the enthalpy, and the x-axis horizontal is the extent of reaction. Okay. There are two types of the reaction pathway diagrams. The simple one only depicts the reactant and product, while the more detailed one, they have the transition or the intermediate. The transition or intermediate, okay, sometimes given as a level, or it can also be given just as a point, because this happens only on very short time. The activation energy is the vertical line distance from the reactant level to the transition or intermediate level. That is the maximum point in the diagram, while the enthalpy change is the level from the reactant to the product. Enthalpy change can be positive when product is higher, can be negative when the product is lower compared to the reactant. Again, both activation energy and enthalpy change must start from the reactant. Enthalpy change always positive, but activation energy is always positive, but enthalpy change can be either positive for endothermic or negative for exothermic reactions. That's it of today. Thank you very much.